In this video, we're going to look at graphing. The first example is a linear equation. We start with the y-intercept, the -3. Our second point can be found using the slope. The slope here is 2, which is the same as 2 over 1, so we go up 2 over 1. And then we draw our line connecting the dots. Use a ruler if you need to. Here we have a basic parabola. A basic parabola starts with the vertex at 0, 0, and then has a pitch of 1, so it goes over 1, up 1 in both directions. To find the second point, 2 squared would be 4, so over 2 would be up 4. And if you want to do another point just to be safe, 3 squared is 9. And then you can connect your dots with a nice curve. Here we have a parabola that's been flipped upside down, so it's going to be the same shape, but just upside down. Here we have a parabola that's been stretched. So instead of over 1 up 1, we're over 1 up 3. So it's a really narrow parabola. Here, the parabola has been shifted down 5. And then it's our usual shape from there. Here we have a horizontal shift. It's to the right 5. Whenever it's in brackets, it's always opposite to the sign. And then from there, we have our usual This example puts a whole bunch of it together. We have a flip, we have a stretch, we have a shift in both the horizontal and vertical directions. The best way to start this is find where your vertex is. The +4 puts us at -4 and the +3 puts us up 3. So this is where your vertex is. From there, it opens downwards, and instead of going over 1 down 1, it's down 2. So we end up with a parabola that looks something like that. This one here we have a cubic. Now over 1 up 1, but then 2 cubed would be 8. And because it's a cubic, it goes in the negative direction on the left-hand side, because a negative cubed is still a negative. If you have an even power, it'll look similar to a parabola, but if you have an odd power, it'll look similar to this with the cubic. And all the stretches and everything work the same with a cubic. So here we have a cubic that's been shifted up 2. So your key point is at 2. It's been flipped upside down, and it's also got a stretch of a half. So instead of going over 1 down 1, we go down a half. And if you look at 2 to the cube, 2 cubed would be 8, but half of that is 4. So you're going to have a graph that looks something like this. Now we have a square root. This will have these key points. And think of it as half of a sideways parabola. And of course, we can do all the stretches and moving the same way. So here, +5 shifts us back 5, and then the 4 puts us up 4. So that would be your starting point. From there, instead of over 1 up 1, it's over 1 down 2, because the -2 stretches it. And we'd have something that looks roughly like that. This one here, we have a 3 minus x under the root. It can also be written like this. So the shift is actually to the right 3, but here with the negative, instead of going to the right, it goes to the left. We can also look at different roots. Here we have the cube root. So it starts off looking very similar. but then it actually also goes to this side as well. Think of it as a sideways cubic function. So any even power, any even root will go up to the right, but odd roots will go in both directions. So this is what we call a reciprocal function. It'll go through these key points, and it'll look something like this. Now, in this case, the x and y axes are what we call asymptotes. The graph approaches, but never actually reaches. Here's a reciprocal function with some shifts. It's easiest to draw in the shifting of the asymptotes first. And then draw in your curve. Now the -1 in the numerator indicates that it's flipped, so instead of top right and bottom left, it's in the other two. Now this example, we have a circle. In particular, this one's often referred to as the unit circle. We have a center at 0, 0, and then a radius of 1. So it's just a small little circle. Now this circle, it's been shifted, and we have a larger radius. So the x plus 4 puts our center over -4, and then the -2 puts us up 2. And remember, whenever something's in brackets, it's always opposite to the sign. Now the 9 is 3 squared, so our radius is 3. So up 3, down 3, right 3, left 3, and then try and connect it as best as you can to make it look as close to a circle as possible. Now let's look at some exponentials. And I'm going to use different colors for the 3 different equations. First, we have y equals 4 to the x. Now, one of the key points here will be the point 0, 1. And then, because it's 4 to the x, at 1, we have a value of 4. 4 to the power of 1 is 4. And our equation looks something like that. Now, with this, we have an asymptote similar to what we had with the reciprocals. Now if we want to look at y equals e to the x, it goes through that point of 0, 1, but instead of being at 4, it's at 1e, or approximately 2.7. And then it has this similar shape, but it doesn't go up as fast. Now lastly, if we look at y equals 8 to the x, again, it goes through that point 0, 1, but at 1, we're already up at 8. So this one is going to go off the graph that much faster. On this slide, we're looking at e to the x and what negative does to it. So as we seen in the last slide, e to the x looks something like this. If we put a negative in front, this flips it upside down. But by putting a negative in the exponent, it flips it left to right. In this exponential example, we have a shift and a stretch. So we still have that asymptote at -6. And normally we'd be 1 above the asymptote, but the 4 puts us 4 above the asymptote. The next point would be 4 times e, 4 times 2.7. So instead of at 2.7 above, we are at 10.9 above, or approximately 4.9. Here we're going to look at some different logarithm equations. Now y equals ln x, which is ln base e, goes through the point 1, 0, and then the next key point would be e1, or 2.71. If we look at the next one, log x, which is log base 10, you still go through 1, 0, but your next key point would be 10, 1. So as you can see, the different bases change the pitch. So this one goes through 1, 0, and then the next key point would be 5, 1. All three of these have the y-axis as an asymptote. Here we have some different flips happening. So y equals ln x, as we looked in the previous video, did something like this. If we put a negative in front, it flips it upside down. If we put a negative inside, it flips it left to right. As always, we can stretch it and flip it and move them around. So the x minus 5 shifts us over to the right 5, but actually puts your asymptote at 5. From there would be 1 over, and then because it's e, it would be at E1, but we're times by 4, so it's up at E4, or approximately 7.74. Here we have a parametric equation, and we wish to graph it. The idea is to put the t in to each equation, find what the x and y values are, and then plot the x and y coordinates. So if we plug the t into the x, we will end up with and then when we plug the t into y, we end up with so now we can plot the points. So at t equals 0, we have -3, -8, then -2.5, -7, -2, -4, -1.5, 1, -1, 8, and then we're already off the graph. So we'll just plot what we can on the graph. Try and connect your dots as smoothly as you can. Another part of graphing is trying to come up with the equation of the graph. Now here we know it's a parabola, so it's going to have something to do with x squared. Locate your vertex. We've been shifted to the left 3, so we know it's an x plus 3 in brackets, and it's been shifted down 1, so a -1. It opens up, so it's positive, and there's been no stretch. Here we have a reciprocal function that's been shifted to the left, and it's been shifted down 1. Biggest thing is look at where the intersection of the asymptotes are. So we know it's x plus 4 on the denominator and -1, y equals, and then it's 1 over because it's in the positive portions. With a circle, it's best to locate the center of the circle, which would be -3, 1. And then from there, you'll see that the radius is 5. So it's x minus 3, or been shifted to the left 3, so it's x plus 3 in the bracket. And then it's been shifted up 1, so it's actually y minus 1 in the bracket. And the radius is 5, so it's equal to 5 squared, which is 25. Now we have a cubic root function. We have this key point So we know it's been shifted to the right 3 and up 3. It's going up to the right, so we know it's a positive, but it's also been shifted, stretched. So it's 2 cubed root of x minus 3. Remember, underneath the root is like in a bracket, so it's opposite to the sign. And then it's been shifted up 4. Now we have a exponential function with an asymptote at 7. So we know it's plus 7 on the end. It's going to be a negative because it goes downwards. And this is where your next nice point is. And you'll see it's 4 below. Our actual key point here hasn't been stretched, so it's a 4 to the power of x. Lastly, we have a logarithm that has been shifted to the left 2. This key point is the same, it goes up to the right, and our next key point is here. So this is 5 over, so this is our base, and this is 4 above, so it's been stretched by 4. So we have y equals 4 log base 5 of x plus 2.